A whistle will indicate that we can make a move. The circuit is an electronic die to which we incorporate sound, so that a whistle indicates that we can press the key to make a move. When pressing, a binary value between 1 and 6 appears on the LEDs, corresponding to the possible values of a die. The circuit. The assembly has several parts. Firstly, we have an oscillator circuit that is responsible for advancing the counter. This circuit works permanently when there is power, and stops when P8 is pressed, as we have zeroed the oscillator input, terminals 1 and 2 of U1A. This clock signal is also used to obtain sound. It is inverted with U1D and is taken, through resistance R6, to the base of transistor Q1, in whose collector circuit we have a speaker that will sound whenever the oscillator is working. The counter circuit is configured to count in binary and ascending from 9 to 15, but by using only 3 LEDs it reads from 1 to 6, using the inverted CO output, carry out, to load the beginning of the count. To connect the power supply, we must activate switch SW1. Functioning. The operation of the circuit is very simple. With the power connected, the speaker should emit a sharp whistle and the 3 LED diodes will light up, due to which the 3 counter outputs are changing at a very high speed. When we say they change, we are referring to the counter counting 1, 2, 6 so that the outputs change state. When we want to make a move, just press P8 to stop the counter and the 3 LEDs will show the output number. As long as we continue pressing P8, the counter will have its output fixed and the speaker will not emit sound, as the oscillator will remain deactivated. Putting it into operation. The circuit should work as soon as we connect the power via switch SW1. If none of the LEDs light up, we will check the power supply on each of the integrated U1 and U2. We will also review the polarity of the LEDs, LD6, LD8, as well as review whether the switch contacts are located in the corresponding place. Experiments. None of the components of this project are critical, so we can modify the value of any of the components. Thus, we can change the frequency of the oscillator to obtain a sound that seems more pleasant to us or to make the clock go slower and check how the counter outputs change, although if it is too slow we will not be able to hear it. We can also modify, without introducing major changes, the polarization of the transistor, in order to vary the speaker's output power. U1A and U1B form an oscillator that turns the speaker on and off, in addition to supplying pulses to the 4029 through pin 15. Inputs A, B, C and D form the number 9 in binary, 1001. Pin 7 remains positive until it reaches 15, when it becomes negative, resetting pin 1, which returns to count from 9 to 15.